this lesson, we're going to look at equivalent statements and how to use logic to show that two statements are logically equivalent. And the symbols that we use for that are either this double wide arrow, or it looks like an equal sign, but it has three lines in it. And so just a quick example of two equivalent statements. We'll start off with the truth table for just plain old P. So we know that P can either be true or false. And we want to show that P is the same as the negation of the negation of P. And if you think of just negative numbers, if you take the opposite of a negative, you get the positive back. So this is similar. The negation of P is false, true. And then the negation of P, well, the negation of a false is true, and the negation of a true is false. And when two statements are logically equivalent, they have the same exact answer column. So when we look at the answer column for P, and we look at the answer column for the negation of not P, we get the same exact truth values in that column. Alright, so let's look at an example here and see which statements are equivalent, are logically equivalent below from A through D. And we'll first start, and we want to see which are equivalent to the given statement here. It is not true that the cat is both adorable and fat. So the first thing we want to do is just determine the simple statements, what P and Q are. So we'll take a minute to do that. You can pause the video if you want and write your own out. So we always state our simple statements in the affirmative. So we've got the cat is adorable is P, and the cat is fat is our Q. So the first thing I'm going to do is first write the symbolic form of the given statement here. It is not true that the cat is both adorable and fat. So it is not true. We use the negation. And in parentheses we'll have the cat is both adorable and fat. So we'll have the cat is adorable, P, and the cat is fat, Q. So this is the symbolic form of our original statement. And then what we want to do is come up with the symbolic form for each of these statements here also. And then in the end, we're going to do a truth table for each one. And those statements that have the same truth value, or the same answer column, will be considered equivalent statements. So pause the video again and just write the symbolic form for A through D. Okay, so for part A, if the cat is not fat, then the cat is not adorable. So that's going to be not Q, and then conditional not P. Part B, the cat is not adorable or the cat is not fat. So since P is the cat is adorable, then we're going to have not P, and that's or. And the cat is not fat, so that's going to be not Q. For C, the cat is not fat and the cat is not adorable. So not Q and not P. And the very last statement, if the cat is not adorable, then the cat is not fat. So the negation of P and conditional not Q. So we've got our original statement written in symbolic form, and then we have our four additional statements. And in order to find out if these statements are equivalent, we want to do a truth table for each one. So again, I highly recommend that you pause the video and set up these truth tables for yourself. We'll start by putting the original statement right here, so the negation of P and Q. And then we'll put the A through D down in the bottom truth table here. So I've written the original statement at the top here, and I've written the four statements from A through D in the top row of the tables below, and we'll do a truth table for each one. And so for this first one, the negation of the P and Q, I'm not going to bother writing P and Q over again because I can just look over here. We talk about sometimes there are, more efficient ways of doing this. I know that the and statement is only true when both are true. So for true, true, I'm going to have a true. For true, false, that'll be false, false, and false. And then my answer column is going to be the negation of those. The negation of a true is false. The negation of a false is true. The negation of a false is true. And again. So here's my answer column for the original statement. Now we'll do a truth table for each of the statements in A through D. And any of those that have the answer column, when the answer column is exactly the same as the answer column for the original statement, that statement will be considered logically equivalent. So we'll start with the not Q, if not Q, then not P. For the negations, I actually think it's a good idea to rewrite these. You try to do this in your head, and it's very easy to lose track. So take a minute or take a few seconds and negate Q and negate P. Now I know for a conditional statement, it's only false when I have a true false. So the first is true. True false is false. This is true, and this is true. So I've got my answer column for the first statement, which does not match the original, so that's not logically equivalent. Let's go in and do our truth table for not P or not Q. So I'll first do my not P's. False, false, true, true. And my not Q's. False, true, false, true. And for an or statement is true as long as one of them is true. So the first would be false, true, true, true. So I know that the second statement is logically equivalent, and we'll move on and we'll check the last two. So again, why don't we fill in our negations right now and get that out of the way. So not Q is false, true, false, true, false, false, true, true. And let's even come over here and get this out of the way. False, false, true, true, false, true, false, true. Alright, so for an and, I know that an and is true only if both of them are true. So we're going to have false, 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 true. That's my answer column. And for a conditional is only false when you have a true false. So I'm going to have true, true, false, true. And here's the answer column. So of the four statements, only the second statement is considered logically equivalent to the original statement. So let's come back up here. The second statement is the cat is not adorable or the cat is fat. That statement is considered logically equivalent to it is not true that the cat is both adorable and fat. Let's try another example. All right. Sometimes it's nice instead of using a truth table. Sometimes it's nice to, if you take a known equivalent statements, you can use them to find another statement that is logically equivalent. And so we know from when we first studied the biconditional that the P if and only Q is equivalent to saying if P then Q and if Q then P. So it says write the following as an equivalent biconditional statement. First write the statement in symbolic form. So I'm going to start off by saying P is going to be it is raining. And then Q I take an umbrella. So the first thing I want to do is take this statement and write it in symbolic form, which if it is raining, then I take an umbrella, is if P, then Q. And if I take an umbrella, then it is raining. That's going to be if Q, then P. And now I know that if I have two conditional statements and they're connected by an and, that's the equivalent of P if and only Q. So I'll take my new symbolic statement and I'll use the words that I have here, my simple statements, and I will write a new verbal sentence that will be equivalent to my original. So P, if and only if Q. It is raining if and only if I take an umbrella with me. Or I take an umbrella. So the original statement, if it is raining, then I take an umbrella, and if I take an umbrella, then it is raining. An equivalent sentence is, it is raining if and only if I take an umbrella. Okay, I'm going to pause. I'm going to stop this video and start the next one up, and the lesson up in the next video.